In our previous video, we looked at how to specify linear regression options in jamovi to answer the research question, what is the relationship between morphological awareness and reading comprehension? In this video, we explore the checking of assumptions in detail. Navarro and Foxcroft explain that there are 6 assumptions to check before interpreting the results of linear regression analysis. Table 5.4.2.1 in your course guide lists these assumptions, where to find the information, and a reminder of what you're looking for. The first assumption is that there should be a linear relationship between the outcome and predictive variables. You can find this information when you do a correlation analysis, or if you download the scatter module using a scatter plot. We're looking for 2 things here. First, from the scatter plot, the variables should have a linear relationship, so a straight line should be able to go through the data and explain it quite well. The next one is to look at Pearson's R, and the value should be at least weak, although moderate would be better. We've already done this analysis in our previous activities, so we know that both morphological awareness and vocabulary have a linear relationship with comprehension. The next assumption is that the predictors should be uncorrelated, or rather not correlated too highly. So again, you can look at Pearson's R, that the R value should not be greater than 0.8. And we can also look at the output from the collinearity statistics, specifically variance inflation factor values. And we'll look at those results just now. The next assumption is the normality of residuals, that after fitting the model, the difference between the prediction and the actual data should result in a normal distribution. We can check this in 2 ways, by using the Shapiro-Wilk statistic and also checking the QQ plot of standardized residuals on theoretical quantiles. The fourth assumption is that there should be homogeneity of variance, or this other word, homoskedasticity. This means that there should not be undue influence on some of the residuals. And so when you look at a plot of residuals versus the fitted data, the data points should be scattered rather than be in a pattern or bunched. The fifth option is that the residuals should be independent of one another. Navarro and Foxcroft do not go into this assumption much in their book, but perhaps we can say that if we have homoskedasticity, that the residuals should then be independent of one another. And finally, we must check that there are no influencer data points. What these are outliers with a lot of leverage, so they pull the regression line out. We can check this with Cook's distance. Now let's return to our output. We specified all these options in the previous video. Let's now go and check. So as we said, we already know that our variables are linearly related because we looked at the scatter plot and did a correlation. For the second assumption, that the variables should be uncorrelated, we've also checked that. We know that the variables have a moderate correlation. But we can also look at the VIF, which is here under collinearity statistics. We do not want VIF to be more than 5, it's 1.28, so the collinearity assumption has not been violated. The next step, we want to look at the normality of our residuals, not the variables themselves. The output of the Shapiro-Wilk normality test is not significant. P is greater than 0.05. So numerically we can see that the residuals should be normal. Just a warning here, the Shapiro-Wilk test also depends on sample size. So in large enough samples, the statistic will always be significant. So it's best practice to look at the QQ plot. We can see that the residuals quite closely follow the normal line, except for a little bit at the bottom. But taken together, we'll say that our residuals are normally distributed. The next point, homogeneity of variance. We look at our residual plots, specifically residuals on fitted, and we can see that these data points are spread out with no particular pattern to them. We can also explore the other plots. We see that there's possibly a problem here with residuals plotted onto the comprehension variable, as there's definitely a pattern in the residuals. However, because the other two graphs also don't seem to have much of a pattern, we will say that this assumption has been met. Finally, we look for influencer data points by integrating Cook's distance, which is all the way up here. We want Cook's distance to be less than 1. We can see here that our maximum value is only 0.1, and so there are no influencer data points. Thus, we can say that our linear regression has met the assumptions, and so we can go on to interpret the model.